Yeah. I'll just do the 7.
I shouldn't need it. I looked over there. You guys
Don't say that. You're gonna will it and do it again.
No, it's
This is square root of 3 over 2. Square root of 3 over 2, 1/2. I know. Square root of 3, 1/2, square root of 2 over 2. Square root of 1/2, square root of 2.
I just wrote something and I don't know this. But it's
And then it just reflected over here.
Well, no, I don't know, but I don't know, like, no,
You should know.
it's not part of this thing, I don't know any other, right?
5 or 6.
Okay guys, we've got the second page of our test this afternoon. And none of this is calculator allowed, so go ahead and clear off your desk, please. Feel free to start as soon as you get it. There's no reason to wait. Now, this one does not have a great place for you to put your name. So please put your name at the top before you put it. Okay, a couple of these are just short answer, so no choice to pick from. You just need to write out what you think the answer is to. A couple of these are multiple choice. But each of these are worth 1 point each. So some of them probably are easier than others, but they're all worth the same. And just like yesterday, I think you're going to have way more than enough time. There's something I'd like to do with you when we finish. But this takes priority, of course. This impacts your grade the most. So please do not turn it in until your name's on it. If you forgot to put your name on it already, do it now. And you have checked to the best of your ability all the questions you got for it. And then if you happen to finish faster than other people, just find something quiet to work on. I will keep track of how many more tests we have out, and I'll let you know when everyone's done. Yeah, that's what they're there for. And those of you that are finished, you'll need to find something quiet to work on. You may not just talk to your neighbor. We got people taking a test that's going to take priority. Sign up, take this. fine if you're still working. Is anybody still going? Okay. So, I do need you to regroup with us here for a minute. I've got couple small things and one important thing to introduce you to. So you do need a blank piece of paper for me. Got about 5 minutes worth of notes. I need to show you what a derivative is and where it comes from. That's what we're going to be doing basically the rest of the semester. Also, number 3 in your binder is a place where I ask you to do your unit reflections. So hopefully you filled out the first 2 questions before we started the test. Just how do you think you were going to do based on how much time you spent. Again, those are not a gotcha thing. Those are really more or less for your reflection. But a couple of the next questions are, now that you've seen the test, how do you think you did? So what I'm kind of hoping that you see out of that is, I don't know, you studied 10 minutes and maybe you didn't do as well as you wanted. So maybe next test you'll spend 45 minutes, whatever. But then there's also a section in there that says like, what type of question or what type of formulas would you wish you had practiced more or memorized or whatever. And I know that stuff is pretty obvious right now because you just finished up the quiz. You're not going to remember in December when we're worried about the semester exam, and you're certainly not going to remember in May when we get to the AP exam. If you write down the things you wish you'd practice more, or even if there's nothing, maybe write down the 1 or 2 types of questions you thought were the hardest. Just so, you know, it'll take you 10 seconds to glance at that, and then you kind of remember what your challenges were in this unit. The other thing, just real quick, I have a strong suspicion on what you guys are going to say, but I asked my other classes. So I will happily stay after school and grade these. But keep in mind that the curve, again, Mr. Myrick, who teaches a section of calculus this year, gets a vote as well. He's out for surgery this week and next week. So his classes are learning some of the stuff that's coming up. And then they're going to take this quiz when he gets back. Anyway, that's their problem to figure out. But I can't promise you what the curve is going to be until he gives his quiz, grades his, and he gets some input. So I give my other classes the option of where I will grade it based on what I think the curve will be, and I can put that in the grade book so you can see how you did. But if I do that, if that's what you guys want me to do, you have to understand that it could go up or down just a little bit based on what the real curve ends up being. So does anyone have a preference whether I grade it the way I think it's supposed to be, or do you want me to just wait until Mr. Meyer gives his and then it goes in correctly? Yeah, what do you think?
I'd like to see the curve personally.
With what I think the curve will be?
Yeah, at least like personally for me. If you want to apply it as a general rule, I think it'd be better just to put it as it is.
Okay, so I'll put it in the way I think it'll end up being, but again, it could be a little bit better for you, a little bit worse for you. It could adjust. So just keep that in mind. I'm not promising you that it stays that way. But since he's out sick and it takes an extra week to get caught up for him, I didn't want y'all to have to sit on it for a week and a half, 2 weeks or something before that. Okay, so just very quickly, I know we are almost to a 3-day weekend, but I need to keep you guys on track with the other classes, and this is what they talked about after the test. So, again, this is on your own piece of paper, so there's like one assignment in the first unit I didn't take up that were really notes. Sometimes I take up the notes, sometimes I don't, but make sure that you copy down what I copy down. Okay, so far in calculus, we have talked about how to deal with 0 over 0. That's a unique problem that you don't know how to do until you learn limits. The second problem in calculus is an extension of this. If I ask you what is the slope of this line, what methods could you do to find that slope? Okay, you could pick out 2 points, and you could count rise over run. Sounds good. What was another way to do that? Point slope form is if you're trying to write the equation of the whole line. I'm just asking, what if you just wanted to know the slope? There's a formula? Yes? Okay. So a way to calculate rise is subtracting the y values, and a way to calculate run is subtracting the x values. That's great until you get to calculus. In the real world, not everything is made up of so many straight linear lines. In calculus, I need to be able to ask you something like this. What do you think the slope of x squared is? Well, what's the problem? You guys know what slope means, right? So for the first time in calculus, slope depends. Every time you've ever been asked slope before, it's been a linear line, which means the slope is the slope. The slope is 3 here, the slope is 3 over there. But in most stuff with curvature, it depends on the x value. So the big secret, or letdown, I guess, is that slope is basically the same thing as derivative. So what we spend all or most of this first semester on, other than the first couple weeks and maybe the last week or two, when we talk about derivatives, it just means slope. Now when we say slope, it kind of implies you're talking about linear, whereas derivative doesn't necessarily mean linear. It could be anything. But what you need to understand is that the slope depends. So sometimes we draw in these little, what's called a tangent line. A tangent line is a good little visual. So like over here at x equals 2, you should be able to see that the slope is something positive. Over here at -2, you should be able to tell that the slope is something negative. What do you think the slope is at x equals 0? 0. You can actually see that, right? It's a horizontal line, which is 0. So I did add this, not a poster, but whatever. This tangent line gives you kind of a visual. We do lots and lots and lots of stuff with tangent lines, because the tangent line is kind of like a visual of what's going on at that instant. You can see the derivative, you can see the slope at that instant. Okay, so derivative, I need you to keep up with me just a little bit here. But let me pick something with curvature. Let's say I want to find the slope right here. I want to know at that instant what is the slope. Now keep in mind, this is very brief today and we have all semester to get to this, but depending on what this function represents, it's in the real world, the slope also means something important in the real world. It's not just not random. So what we could do with what you already know is I could pick a second point over here, and I am going to find that point and say that it's a little bit more to the right than the first point, and I'm going to call the distance you have to scoot from point 1 to point 2 h. Okay, let's call this point, I don't want to use numbers, because if I use numbers you think it only works there. I'm going to call this first point x, comma, f of x. And of course, f of x just means the y value when you plug in x. What is the point, what's the x value of the second point? Perfect, x plus h. It's whatever this was, plus however much you scoot to the right. And so his y value is going to come from plugging in x plus h into f of x. So what I'm going to do is I'm going to take these 2 points, point 1 and point 2, and I'm going to find the slope of this. This is called a secant line. A tangent line touches your graph at once. A secant line touches your graph more than once, like this, 2 different places. Well, I've got 2 generic points, and I'm going to find the slope of this secant line, this blue line. So you can fall back on the slope formula you know, or I hope you know. Nobody said anything about it a minute ago. And then you can plug in y2, subtract y1 over x2 minus x1 Okay, you can see that the denominators has some like terms we can combine together, plus x minus x. Now there's one last thing here, and all of a sudden you just discovered the definition of a derivative. There's only one more thing I need to say before we have the definition of a derivative. If I don't want the slope of a secant line. This blue line has a way different slope than this black tangent line. So, what would make the slope of the secant line closer to being the slope of the tangent line?
A closer point.
Okay, good. You want the second point to get closer, right? So you also want h to get smaller. For the second point to get closer to the first point, h has to get smaller. So you have a way to say that now. You can't say h is 0 because you get division by 0. But you can say the limit as h approaches 0, and that is the standard definition of a derivative. I just want you to see, because conceptually, honestly, you don't have to derive this or anything, but conceptually, we're using derivatives all semester. You might as well know where it comes from. It's just a fancy slope formula with generic points, and then I'm trying to say I want the second point to be as close to the first point as possible. I want h to approach 0. This is the idea of where a derivative comes from. So, derivative just means slope. There's a couple other little things I would like to show you, but I did push you pretty close to the bell. So, any quick questions? Again, obviously, yeah.
This is on your website.
It's on the class recording, but
Okay. And the website, the class recording on the website.
the class recording's on a calendar. It's at the top of the website.
Okay.
Yep. Okay.